Yes, thank you very much. I will start with this picture. It's a picture of something that we get to see every day. We are used to see it. Yet, this is probably the kind of picture that should not happen in a sufficiency world, in the world of sufficiency. Why? Because in the world of sufficiency, we would have found solutions to avoid replacing buildings while to ensure the well-being of all, while avoiding the use of new resources, while avoiding the replacement of buildings. We are not there yet because not replacing buildings, avoiding real estate investment, avoiding construction activities is a huge challenge. It requires changing the entire economic systems of the country, but it doesn't mean that we cannot do anything in the meantime. And something that we can do is to find a way to replace, to upgrade the current building stock without needing natural resources, so while avoiding natural resources. And one way to do it, the one that I will explain here, is related to giving new value to the waste that is actually produced by construction activities. Currently, concrete waste is the most abundant waste in Switzerland. What are the end of life for this type of waste? Most of it is landfilled, and another part is further crushed down, which requires new energy, and reused as recycled aggregates in what we call recycled concrete. Yet, to produce recycled concrete, we need new inputs of water, sand, and cement, so still need for natural resources, still production of waste, and still generation of a huge amount of CO2 emissions. So this is not very sufficient, and this is happening everywhere. So it's a resource that is available. It's not an abundant resource, but it's a resource that is untapped at the moment. This map here of Switzerland shows the 70,000 buildings that have been demolished in Switzerland, so from 2000 to 2022. So we are demolishing everywhere, and we have this resource available. What can we do with this waste? Well, we can do something similar to what was done here in the Netherlands in 1986, where the top floor stories of the buildings have been carefully dismantled, so the concrete panels and slabs have been cut, stored, and then reused a few streets away in order to build the building on the right-hand side. The building on the right-hand side is of perfect quality. I mean, it fulfills all standards of construction. It's just as good as performant as regular concrete, yet it avoided the use of natural resources, it decreases the generation of waste, and drastically reduced CO2 emissions. This is one of the very few examples of concrete reuse, and the real question is, why is it still a niche activity? Why isn't it more common? And probably that the main reason is related to something that was actually discussed here at the roundtable, is the fact that change is very difficult to do, and in particular for component reuse, there are a series of new unknowns that are there, and we fear the unknown. We are humans. We fear the unknown. Will we be able to procure the material? Will we have enough materials on time? What will be the quality of that waste? Will it be of sufficient quality or not? What are the new financial risks and so on? So these are new questions, and because we are not used to that activity, it's very hard to embrace them. And the issue is not that, it's a risk. The issue is that it's a new type of risk. In the construction industry, and the stakeholders take risk every day. It's very common to take risks, but it's okay because we take the same risk over and over for decades. We take the same risk, and so we are confident in taking the risk. As soon as you want to address new types of risk, there are barriers, and you have to address them. And so the issue is that we need to build trust in this new type of activity. And what is the product that is most reused on Earth? These are the banknotes and the coins. You put a value on this piece of paper just because you trust the fact that in the near future you will be able to exchange this piece of paper for another product. But no one guarantees you for sure that you will be able to make that exchanges, that value exists. It's only trust that you have because, I mean, you were able to use that banknotes yesterday and 10 years ago. So yes, we trust that in the future we'll be able to do that. And as researcher, we see our goals as like this. So how can we help the industry to build trust in these new activities? And as many mission-oriented researchers, we combine different disciplines, architects, engineers, computer scientists, in order to tackle that challenge. One of the very first things that we did was to develop tools for engineers and architects in order here, for instance, to allow them to optimize the matchmaking between a stock of components that are ready to be reused and a new project. So how can we make sure that the products are well placed placed at the right locations, that we are not using too much resources, that we're actually reducing CO2 emissions or not? It has been implemented in this building here, but it's not because a tool exists that people will use the tool. And here, I want to emphasize the importance of precedence. So we need precedence, the industry need precedence to build this trust. And we had the chance to collaborate with students at EPFL, but also with local companies here in Lausanne, to show that this building in Renan didn't have to be demolished fully, but there is an alternative consisting in cutting carefully the components, realizing that there is an embedded technology of value in that concrete and that it's worth being reused. And it's been reused in this pavilion that is built here at Écu Blanc. This is a project led, managed, constructed by EPFL students. They actually have a booth here in the hall, so if you have questions, you can ask them. Showing that low-tech, I mean, we can still build new buildings employing only or mainly low-tech activities. Yet, I mean, these are nice pictures, but there is a need for engineering, for development behind. There is a need for new connection systems. There is a need to assess the quality of this waste. What tools can we develop in order to assess, to make sure that this is of sufficient quality? There is a need to understand how the construction practice happened 50 years ago, so historical studies on the construction activities, and so on. There is a need to understand how the change of structural system can trick the things and ensure the reuse of these old slabs while ensuring the that current norms of construction are fully fulfilled. But I mean, there's nothing new here. The point is really to show to engineers that all the knowledge they've learned when they were students is actually useful for new types of application. And this is also a way of implementing innovation from the bottom up, so showing that changes may happen quickly. And of course, if you do this reuse, you avoid waste, you avoid the use of natural resources, but you're also decreasing CO2 emissions drastically. So most of the embodied carbon in Switzerland, in developed countries, is inside, it's related to the construction industry. Most of the embodied carbon in buildings is related to the production of slabs. And so if you can decrease that, you really have an impact. So just reusing this old steel, this old slab, allows you to decrease by 90% the CO2, the greenhouse gas emissions related to the construction of that slab. And if you have to transport these concrete pieces from the other side of Switzerland, you can still achieve a 75% reduction. So this morning, Amina Saheb presented this opposition between sufficiency and efficiency. So sufficiency doing the right things, efficiency doing the things right. Here is an example showing that it also makes sense to do the right things right. So this is the result of a master thesis by a student. She started with inputs, so 2 buildings that were about to be demolished in Basel, and then the other input was a floor plan of a new building that is about to be constructed on the same location. And every color means a different reinforcement bars in the slab, so different stiffness, different strengths in the slabs. And it's like a puzzle that you have to optimize. So how can you cut the pieces from the existing buildings, reassemble them, rotate them, and so on, in order to make sure that the new building can be constructed, that you are minimizing the need for strengthening of this old material, and that the new building is safe. So achieving both low-tech, sufficient, and high-tech optimization and efficient design. From an economical point of view, it makes sense to cut the slabs, but it doesn't make sense to cut everything in the building that has to be replaced. And so we still have these aggregates, this rubble that is there available. And we are exploring ways of easing the reuse of this rubble by implementing digital improvement at key locations. So the point here is not to fully digitalize the full process. It would take a lot of time, and we don't have that time. Sustainability has to be achieved today. Actually, it had to be achieved 50 years ago, so we are already late. So we need low-tech construction, but at the same time, we have high-tech solutions available. So the question is where to apply key digital improvements, for instance, with visual recognitions, with machine learning, with some automations, but not all of it, while allowing the reuse of this waste, and while putting the workers at the center of the process. Because changes have to happen now, and this has to be quickly implemented. So we don't see an opposition between high-tech and low-tech. We rather see the need for using high-tech in a pragmatic way in order to improve the use, to expand the use of low-tech innovation. Thank you very much.
Thank you so much, Corentin, for setting the stage with such compelling insights into a pragmatic approach to building technologies. We have a couple of questions here from the audience that I want to address, and this would be the first one. How do you ensure that the foundation of the building are sufficient for the new building?
That's very technical questions. Yeah, so there are ways to reuse old concrete in order to make the foundations first. There are also ways to make sure that the existing foundations can help the foundations. And if you need new foundations, you cast new foundations. I don't think we should be dogmatic and avoid the use of new materials. It's way more challenging than that. But it just doesn't make sense not to reuse this resource that is available. No.
All right. There's one that says, how does sufficiency get paid off or get financed or fit into our current profit economy and business structure and incentives or incentivizes our continuous growth? That makes sense.
Yeah. So I will speak for what I presented here, which is only a small part of the economy. But what we see is that it's a new type of calculations to do. It's a new balance to find. So there are new costs. There are also new opportunities for benefits, and the question is to find ways to find the new balance in between these new costs and the new benefits. And I believe it's the same with every new innovation.
All right.
I'm not an economist, so this is my...
Okay, so we're going to get to the rest of the questions now. Thank you so much, Corentin, for this invigorating talk.